welcome back to Study Room. In the previous lecture, I taught you a topic of mensuration, that was surface areas of cube, cuboid and cylinder. In today's lecture, we will discuss a new topic of mensuration, that is volume of a cube, a cuboid and a cylinder. So let's get started. The first thing that we'll learn is finding volume. So basically, volume is the amount of space that is occupied by a three-dimensional structure. And cubic units is used to find out volume because cube is the most convenient solid shape that we have in three dimensions. Now, if we have to find the volume of any solid, then we will be dividing it into cubic units. Now, we will be discussing the three generally used cubic units which is used for the measurement of the volume of any solid. So they are, the first on the list is 1 cubic centimeter. 1 cubic centimeter means 1 centimeter multiplied with 1 centimeter multiplied with 1 centimeter. So centimeter, centimeter, centimeter 3 times gives us 1 centimeter cube. Now, we can convert this centimeter into millimeter as well because we know that 1 centimeter is equal to 10 millimeters. So, I'll be converting 1 centimeter into 10 millimeter and write 1 centimeter as 10 millimeter multiplied by 10 millimeter multiplied by 10 millimeter, which ultimately gives us 1000 millimeter cube. That can also be written as 10 to the power 3 in standard form. So we can say that 1 centimeter cube is equal to 10 to the power 3 or 1000 millimeter cube. So this is a commonly used measurement for finding out the volume. Another commonly used cubic measurement is 1 cubic meter. Now 1 cubic meter means 1 meter multiplied with 1 meter multiplied with 1 meter. That gives us 1 meter cube or 1 cubic meter. Now, we know that 1 meter is equal to 100 centimeters. So, 1 meter cube can be written as 100 to the power of 3 centimeter cube. The next generally used measurement, that is cubic unit, is 1 cubic millimeter. Now, 1 cubic millimeter can be written as 1 millimeter multiplied with 1 millimeter multiplied with 1 meter. That gives us 1 millimeter cube. Now, we also know that millimeter can be converted into centimeter. How? We know that 1 millimeter is basically equal to 0.1 centimeters. So, 1 millimeter is 0.1 centimeter. So, that gives us 1 millimeter cube as 0.1 centimeter multiplied with 0.1 centimeter multiplied with 0.1 centimeter. So, this ultimately gives us 0.1 to the power of 3 centimeter cube. So these are the three basic measurements that we use to find out the volume of any solid. Now we'll be dealing with a topic that is volume of a cuboid. So what is the volume of a cuboid if L is the length, B is the breadth and H is the height? So the volume of a cuboid whose length is L, breadth is B and height is H is length multiplied by breadth multiplied by height. Now just observe over here. We know that length into breadth is the area of a rectangle whose length is L and breadth is B centimeters. So this length into breadth can also be written as the area of the base of the cuboid, because we know that the base of the cuboid is rectangular in shape. So this length into breadth is actually the area of the base of the cuboid. So ultimately, volume of a cuboid can be represented in a different way, that is, volume of a cuboid is the area of the base multiplied with the height. Now that we have learned the direct formula of calculating the volume of a cuboid, let us try this problem. So in this problem, we have 36 cubes of equal size and they have been arranged to form a cuboid in different ways. These are the two different ways in which the 36 cubes have been arranged to form a cuboid. So we have to find out the dimensions of this cuboid, that means the length, breadth and height, and then ultimately find the volume. So over here we can see that the length of the cuboid is 9. So we'll write 9 as the length of the cuboid. The breadth of this cuboid will be 1. So we'll write 1 over here. And the height of the cuboid is 4. Now, in order to find the volume, the formula is length multiplied with breadth multiplied with height. So we'll have 9 multiplied with 1 multiplied with 4. 9 multiplied with 1 and 4 gives us 36. Moving on to this problem. Here the length of this cuboid is 6. Breadth is also 6. and height is 1. So the volume will be length multiplied with breadth multiplied with height. That is 6 multiplied with 6 multiplied with 1, which gives us 36. So we can say, from here we can conclude that if we are taking 36 cubes and arranging it in different possible ways, the amount of space that it is occupying, which is the volume, remains the same in both the situations. So in whatever way we place, the amount of space, that is the volume, remains constant. Now let us try finding the volume of these two cuboids given. So over here, the length of this cuboid is 8, breadth is 3 and height is 2 centimeters. We know that the formula for calculating the volume of a cuboid is length multiplied with breadth multiplied with height. The length given over here is 8, breadth is 3 and the height is 2. But the unit of this volume will be centimeter cube, because each of the length is given in centimeter, so the volume's unit will be centimeter cube. So when we multiplied 8 with 3, this gives us 24, and 24 multiplied with 2 gives us 48 centimeter cube, which will be the volume of the given cube. Now, moving on to the next problem. In this problem, the area of the base of the cuboid has been given as 24 meters square and the height has been given 2 meter. So we know another formula for calculating the volume of a cuboid, and that is volume of a cuboid is equal to the area of the base multiplied with the height. The area of the base given is 24 meters square and height given is 2 meters square. So 24 multiplied with 2 gives us 48, and the unit of volume here will be meter cube. Now we'll talk about the volume of a cube. Now, a cube can be called a special case of a cuboid. Why? If in a cuboid, the length, breadth and height all become equal to each other. So in that case, a cuboid becomes a cube. So a cube can be called a special case of a cuboid in which length is equal to breadth is equal to height. So in case of volume of a cuboid, we used to write length multiplied with breadth multiplied with height. Let's say in a cube, what happens? Length, breadth and height becomes equal. So let's say length equals breadth equals height equals L. If we are taking L as a unit to represent length, breadth and height, because in a cube, each of these length, breadth and height are equal. So the volume of the cube will be L multiplied with L multiplied with L. That ultimately gives us L cube. So the formula for calculating the volume of a cube will be L cube, where L is nothing but each of the edges of the cube. Now that we have learned the formula for calculating the volume of cube, let us try doing some problem. So the first problem given over here is find the volume of the cube whose side is 4 centimeter. So each of the side is 4 centimeter. That means L is given as 4 centimeters. Now we know that the formula for calculating the volume of a cube is volume is equal to L cube. So here L is 4, so the volume will be 4 cube. So ultimately volume will be 4 multiplied with 4 multiplied with 4. That gives us 64, and the unit of the volume will be centimeter cube, because each of the length of the side was given in centimeters. Now we have another cube in which each of the side is 1.5 meter. That means L is equal to 1.5 meters. So the volume of this cube will be equal to L cube, that is 1.5 whole cube. Now 1.5 whole cube means 1.5 multiplied with 1.5 multiplied with 1.5. This ultimately gives us 3.375, and the unit of this volume of cube will be in meter cube. So always focus on the unit. If each of the side is given in meter, the volume's unit will be in meter cube, and if each of the side is given in centimeter, the volume's unit will be centimeter cube. Now let us try solving this problem. Over here, we have been given 16 cubes of equal size, and we have to arrange it in different setups in order to form a cuboid and then calculate the volume and the surface area. Now, let us consider that the cube that has been given to us is of 1 centimeter length. That means the length of each of the side of the cube is 1 centimeter. Now, in the first setup, we will be arranging all the 64 cubes in a single line such that the cuboid so formed will have a length of 64 centimeters, because when we are arranging 64 cube in one line, the cuboid subform will have a length of 64 centimeters. And the breadth of this cuboid will be 1 centimeter. And the height of this cuboid will again be 1 centimeters. Now, let us calculate the volume of this cuboid. The volume of this cuboid is length multiplied with breadth multiplied with height. So it's 64 multiplied with 1 multiplied with 1, which ultimately gives us 64, and the unit will be centimeter cube. Now let us find the surface area. So we know that the formula for calculating the total surface area of a cuboid is 2 times length breadth plus breadth height plus of length height. So over here we'll put the values of length, breadth and height. So we have length as 64 and breadth as 1. So length multiplied with breadth will be 64 multiplied with 1, that is 64. Breadth height, that means 1 multiplied with 1, that gives us 1. And then length height, again that is 64 multiplied with 1, that is 64. So 64 plus 64 plus 1 gives us 129. So answer will be 2 multiplied with 129, which ultimately gives us 258 centimeter square as the total surface area when we are arranging the 64 cube in this straight line fashion to form a cuboid. Now let's try arranging these 64 cubes in a different way. Let's say we will be taking 16 cubes in one line and then again taking 16 cubes on the other line. Now join these two lines. Now place 16 more cubes on top of the first line and 16 more cubes on top of the second line. Now this setup of 64 square forms a cuboid whose length will be equal to 16 centimeters. Breadth will be equal to 2 centimeters, because when we are forming the cuboid in this way, the breadth will take up 2 cubes. So it will add up 1 centimeter plus 1 centimeter, that is 2 centimeters. So the breadth over here will be of 2 centimeters. And the height is also taking up 2 cubes because we are placing 16 cubes in one line, 16 on the other line, joining them up and then placing a similar setup of 16 and 16 on top of these two lines. So ultimately the height will have 2 cubes. That means the height of this cuboid will be 1 centimeter plus 1 centimeter, that is 2 centimeters. So the height again will be equal to 2 centimeters. Now let's calculate the volume of this cuboid. The volume will be length multiplied with breadth multiplied with height. So we have 16 multiplied with 2 multiplied with 2, which gives us 16 multiplied with 4, that is 64 centimeter cube. Now let's calculate the total surface area. The total surface area of the cuboid is 2 times length breadth plus breadth height plus length height. So we have length height over here. Now, length multiplied with breadth, that means 16 multiplied with 2 gives us 32. Breadth multiplied with height, that means 2 multiplied with 2 gives us 4. And again we have length height, that means 16 multiplied with 2, that gives us 32. Now, adding up 32 with 4 and again 32 gives us 68. This is 68 over here. So our final answer will be 2 multiplied with 68, that is 136 centimeter square. Because this is the area. Area is always square units. Volume is always cubic units. So from here we can conclude that if we are taking 64 cubes, arranging it in different setups to form a cuboid, the volume will always remain same. The total area, the total space basically, that the object will be occupying remains the same. But in different setups, the total surface area of the substance will not be same. So from here we can conclude that even if the solids are having same volume, it is not necessary that their total surface area will also be same. Over here, in this case also the volume is 64, in this case also the volume is 64. But in both the cases, the total surface area of cuboids are different. Here it is 258 and here it is 136. So it is not necessary that volume of that substances having same volume will have the same surface area. They might have different surface area as well. Let's try solving another question. A biscuit company sells biscuit. For packing purpose, they use 2 different types of cuboidal boxes. Box A has a dimension of 3 centimeters, 8 centimeters and 20 centimeters. Box B has a dimension of 4 centimeters, 12 centimeters and 10 centimeters. We have to find that which of the box from the given A and B box will be more economical to the company. So basically we have to find out the total surface area of box A and box B and then compare them. From box A and B, whose total surface area will be less, will be more economical to the company, because the box having lesser total surface area will cost the company less and henceforth it will be more economical. So let's calculate the total surface area of each of the boxes. So in the first case, box A, the dimensions given to us are 3, 8 and 20. So let's say the length is equal to 20, breadth is 8 and height is 3. So over here, the formula for calculating the total surface area is 2 times length multiplied with breadth. That is 20 multiplied with 8 gives us 160. Plus breadth height, that is 8 multiplied with 3, 24. Plus length height, that is 20 multiplied with 3, that gives us 60. This is 2 multiplied with 160 plus 24 plus 60 gives us 244. So ultimately the total surface area of box A will be 488 centimeter square. Now let us calculate the total surface area of box B. In case of box B, the dimensions given are 4 cm, 12 cm and 10 cm. So let us take length as 12 centimeters, breadth as 10 centimeters and height of the box as 4 centimeters. So over here, the total surface area will be 2 times length breadth plus breadth height plus length height. So length multiplied with breadth gives us 120. Breadth multiplied with height gives us 40. And length multiplied with height, that is 12 multiplied with 4 gives us 48. So we have 2 multiplied with this, adding up this total quantity will give us 208. So this gives us 208 and 2 multiplied with 208 gives us 416. So the total surface area of box B is 416 centimeters square. So over here we can observe that the total surface area of box A is more than box B. So box B will be more economical to the company because it will be costing less for the company to make these box B. So box B is more economical. So the answer over here will be box B is more economical to the company. The reason will be that its total surface area is less than box A. Now, can you suggest any other dimensions which will have the same volume? That means it can occupy the same amount of thing within it. The volume of the box will be same, but it will be more economical to the company. That means it will have a lesser total surface area than box A and box B. Let's try it out. If let's say we are taking the length of the box as 10 centimeters, breadth of the box as 8 centimeters, and height of the box as 6 centimeters. Let us try finding the total surface area using these 3 dimensions. Because if we have the length, breadth and height as these dimensions, then also the total volume remains the same, that is 480 centimeter cube. But we have to make an economical box, that means the total surface area should be less than box A and box B. Let's try finding the total surface area. Formula is again the same, 2 times length multiplied with breadth, that is 8 into 10, 80, plus breadth multiplied with height, 6 into 8 gives 48. Plus length multiplied with height, that is 60. So over here we have 2 multiplied with, adding these 3 quantities gives us 188. So this is 2 multiplied by 188, that gives us 376 centimeters square as the total surface area. So we can say that if we take the length of the box as 10, breadth as 8 and height as 6, then the box will be able to occupy the same amount of substance within it, that is the volume will remain the same. But it will be more economical to the company. It will cost them less because the total surface area of this box is more than box A. Sorry, it is less than box A and box B, which is both of them. Now that we have learned calculating the volume of a cube and a cuboid, let's move on to a cylinder. Now let us consider this as a cylinder where the radius of the cylinder is represented as capital R and the height of the cylinder is h. So, the volume of the cylinder is nothing but the area of the base multiplied with height. So, the area of this base is circular shape. we know that the area of the circle whose radius is r is given as pi r square. So the area of this base will be pi r square. And it should be multiplied with the height in order to get the volume of the cylinder. So the height of the cylinder is h. So we'll multiply pi r square with h, which will give us pi r square h, and this is the volume of cylinder. So whenever we have to calculate the volume of cylinder, we'll be using this formula. Put the value of radius and height in this formula, and thereby we'll be getting the volume of a cylinder. Now let us try finding the volume of the given cylinder. So the first cylinder that has been given to us has a radius of 7 centimeters and height of 10 centimeters. We know the formula for calculating the volume of a cylinder is pi r square h. So we'll put the value of radius and height. Pi means 22 by 7. R square means the square of the radius. That means 7 multiplied with 7. And the height given is 10. So the 7 will get cancelled out with this 7. So we are left with 22 multiplied with 70, which gives us 1540. And the unit of volume will be centimeter cube because the radius and the height is given in centimeter. Now let's calculate the volume of this cylinder. In this case, the volume has to be calculated, but here the radius is not given. Instead of radius, we have been given the area of the base of the cylinder. So we know another formula of the cylinder, that is area of the base multiplied with the height. So the volume will be area of base, which is 250 meters square, multiplied with the height of the cylinder, that is 2. This gives us the volume as 500, but the unit will be meter cube because the area of the base and the height, both of them are given in meters, so the volume will be meter cube. Now in this chapter, we have used two words a lot. One is volume and the other is capacity. So these two words are almost the same. There is not much difference. The only thing is that volume is used to refer the amount of space that is occupied by a given object. But in case of capacity, capacity refers to the quantity that a container can hold. If I am saying that the capacity of this bottle is 1 liter, so that means that it can hold 1 liter of water. But if I say that the volume occupied by this bottle is 10 centimeter cube, so this is the space that the bottle is occupying. So the difference is that when we are talking about capacity, we can even use another unit, that is liter and milliliter. But when we talk about volume, we basically use the cubic units like centimeter cube, millimeter cube or meter cube. Now, let us learn the conversions. The conversions of the unit of liter, milliliter into centimeter cube and meter cube. That means the conversion units for capacity and volume. So in case of volume, we use cubic units, and in case of capacity, we can also use liter and milliliter. So the basic conversions that are important and will be useful in solving problems are that 1 millimeter is equal to 1 centimeter cube. And when we talk about liters, 1 liter is equal to 1000 centimeter cube. Now, 1 meter cube is equal to 10 lakh centimeter cube. We know this because 1 meter equals 100 centimeters. So 1 meter cube will be 100 multiplied with 100 multiplied with 100. That gives us 10 lakh centimeter cube. So this will be equal to 1000 liters. So when we have to convert 1 meter cube to liter, we will use this formula, that is 1 meter cube equals 1000 liters. And when we have to convert liter into centimeter cube, that will be 1 liter is equal to 1000 centimeter cube. Now let us try solving this problem, which is based upon a cuboid. The height of the cuboid needs to be calculated when the volume of the cuboid is 275 centimeter cube and the area of the base is 25 centimeters square. To solve this problem, we have to use this concept. We know that the volume of a cuboid can also be written as the area of its base multiplied with height. So basically the volume is area of base multiplied with height, and this gives us the volume. So we will have to find this height, which is unknown. So in order to find the height, we can write height is equal to volume divided by the area of the base. So basically, height will be equal to, the volume given in the question is 275 centimeter cube. So it's 275 centimeter cube. And the area of the base is 25 centimeters square. So it will be 25. Now when we cancel this up, 25, 11 times gives us 275. So the height will be equal to 11 centimeters. Now let us try solving another question based on cuboid. So there is a go down in the form of cuboid that measures 60 meters, 40 meters and 30 meters. How many cuboidal boxes can be stored in it if the volume of one box is 0.8 meter cube? So in this question, what we have to do is, we have to first calculate the volume of the cuboidal go down. And then we have to divide that volume with the volume of one box in order to get the number of boxes that can be occupied in the whole go down. So let's first find the volume of the go down. So volume of the go down will be equal to the volume of a cuboid, because the go down is in cuboidal shape. So the volume of the cuboid will be equal to length into breadth into height of the go down. Length is 60, breadth is 40 and height is 30. So we have 30 multiplied with 40 multiplied with 30. 60 multiplied with 40 multiplied with 30. So this gives us 72,000 and the unit will be meter cube. Now I told you that if you have to calculate the number of cuboidal boxes that can be stored, then you have to divide the volume of the go down with the volume of one cuboidal box. So over here we'll have the number of boxes that can be stored is equal to the volume of the go down divided by the volume of one single cuboidal box. Volume of one box. So here we have the volume of the go down as 72,000 and we have to divide this with the volume of one box, which is given in the question as 0.8 meter cube. So this will be 0.8. Now we can calculate it in this way. We'll remove this decimal point and take 10 on the numerator side and cancel this 8 with 72,000. That will give us 9,000. 9,000 multiplied with 10 gives us 90,000. So we have the total number of boxes that can be occupied in the go down is 90,000. Now over here we have a problem based on cylinder. There is a rectangular sheet of paper whose width is 14 centimeter. It is rolled along its width to form a cylinder whose radius is 20 centimeter. Now we have to calculate the volume of the cylinder and we have to use 22 by 7 in place of pi because the value of pi is 22 by 7. So the first thing to remember over here is that when this rectangular sheet of paper is folded to form a cylinder along its width, then the width of this rectangle will become the height of the cylinder. So we can say that the height of the cylinder will be equal to the width of this rectangular sheet of paper, which is equal to 14 centimeters. And the radius of the cylinder has been given as 20 centimeters. We have to calculate the volume of the cylinder. For calculating the volume of the cylinder, we use this formula, that is pi r square h. In place of pi, we will put 22 divided by 7. R square means 20 multiplied with 20 and the height of the cylinder is equal to the width of this rectangular sheet of paper, that is 14. So multiplied with 14. This 7 will get cancelled up with 14, leaving behind 2. Now we'll multiply 22 with 20 with again another 20 and then 2, and this gives us 17,600. So total volume of this cylinder will be 17,600 and the unit will be centimeter cube. Now we have another question based on cylinder. We have a rectangular sheet of paper and the dimensions are 11 centimeter as the length of the rectangle and 4 centimeter is the breadth of the rectangle. Now this rectangular sheet of paper is folded to form a cylinder whose height given is 4 centimeter. We have to calculate the volume of a cylinder. We know the formula for calculating the volume is pi r square h. But in this question, we are given only with the height of the cylinder. So we have to calculate the radius of the cylinder using some other details given in the question. The other details are that the length of this rectangular sheet of paper using which the cylinder has been made is 11 centimeters. So from here we can say that the length of this rectangular sheet of paper will be folded in this way. So the length of this rectangle will be equal to the circumference of the base of the cylinder, which is equal to 2 pi r. So length is equal to 2 pi r. So here we can say that length will be equal to circumference, that is 2 pi r. So 2 pi r is equal to the length, that is 11. So from here we have 2 pi can be taken as 22 by 7 multiplied with r is equal to 11. So from here we get r is equal to 11 multiplied with 7 divided by 2 multiplied with 22. So this gives us 11 ones, 11 twos, 22. So ultimately we have radius is equal to 7 by 4 centimeters. Now we will put the value of radius and height in this formula of volume to ultimately get the volume of the cylinder. So the volume of the cylinder is pi, that is 22 by 7. Radius is 7 by 4, but we have to take the square of the radius, that means 7 by 4 multiplied with 7 by 4, and the height of the cylinder is 4. So the 7 will get cancelled out with this 7, 4 will get cancelled out with 4. Over here we'll write 2, 11 times 21 and 2 times 4. So we are left with 11 multiplied with 7, that is 77 divided by 2, which gives us 38.5 centimeter cube. So the ultimate volume of this cylinder will be 38.5 centimeter cube.